Hello, in this video we're going to look at some word problems involving trig functions. So let's take a look at this one. George and Dana get on a Ferris wheel which is 1 meter off the ground. The diameter of the Ferris wheel is 20 meters. Their ride lasts for 2 minutes, in which time the Ferris wheel makes 1 revolution. Model the situation with a sinusoidal function with variable t in seconds. All right, so this question is asking us to take this word problem, which you can imagine, right? George and Dana, they're at a carnival on a Ferris wheel, and we want to model their situation, what they experienced in terms of their height as they traveled up and down. And we can imagine, right, if we're on a Ferris wheel, so maybe we'll draw our Ferris wheel here, and they're getting on it down here at the bottom. Here's our little Ferris wheel seat. All right, we've got some people in here, 1, 2 people. We can imagine that they're going to go around, up to the top, and then back down. And so their height is going to go up and then down. If we were to draw it on a graph, it would look something like this. They would start 1 meter off the ground because they've climbed onto a platform. We can almost imagine the ground is here, and they're 1 meter off the ground already. And so they're here. They're going to go up, get to the top, and then come down. Now, I didn't draw that the greatest, but that's kind of like the rough sketch. And what we would realize is because they're traveling in a circle, they would be making a sinusoidal graph or a trig function. So it would look kind of like this. So sinusoidal, this just means trig. So we're going to be using either sine or cosine. And I think based on the graph I drew here, because it looks like a hill or a valley, I'm thinking we're probably going to use cos. But we're going to need all of the values, right? We're going to need the a, the b. We're going to use t instead of x because they told us to use time for seconds. We're going to need the c and d. We're going to need all sorts of values to get our trig function. And to do that, we're going to need more information on our sketch. So it's almost like we have this extra layer. On the problems we worked on in the previous lesson, we were given the picture and we had to come up with the equation. Now we're given the words, and from the words we have to draw the picture, and from the picture we have to come up with the equation. So there's this extra step where we have to go to the picture from the words. And I've already done part of it. This 1 meter off the ground means that the graph starts at 1 meter. Then the diameter of the Ferris wheel is 20 meters. So this is 20, which means that the top of their experience on the Ferris wheel will be at 21 meters. Because obviously if they were on the ground, which is 1 meter up, then they went all the way to the top, they'll be 20 plus 1, so at 21. That's going to be kind of that top point over here. Now it says it took them a total of 2 minutes, but we want to measure in seconds. So 2 minutes is going to be 120 seconds, right? 60 seconds in a minute. So 60 plus 60 is 120 seconds. So this is how long it takes them to do 1 full revolution. So all the way up and all the way down is 120 seconds. Now, we could add some other pieces of information. For example, this will be 60 seconds because we know it's halfway between 0 and 120. So if we're wondering when the most fantastic moment of the Ferris wheel would be, of course, it's going to be at the very top after 60 seconds. But leaving aside the emotions of the experience, let's go ahead and see if we can find A, B, C, and D. Now, A, if we remember, is going to be the amplitude. It's the vertical stretch, or we can do top minus bottom over 2, which will be 20 over 2, which will be 10. B is going to be 2 pi over the period. Now the period is 120 seconds because that's how long it takes to repeat or to have 1 revolution. Okay, right, that is pi over 60. C is always the tough one, so we're going to leave that for right now. D is a formula. We're going to be top plus bottom over 2. So 22 over 2, so 11. Now cos, we know, starts like this, right? If we're going to draw a cos graph over here, the regular cos graph looks like this. And so if we're thinking of a C value, we either need to find a point that begins the cos graph, like a point at the top of the valley, So you could realistically think, oh, this point looks like the beginning of a cos graph. And so you could argue that this point will give you your C value. Or if you prefer, if you don't like using a C value, you could just set C to 0. And you could say it looks like our whole cos graph is good to go, but it's been reflected. Because instead of going down and then up, our cos graph goes up and then down, which means that the A value is going to be negative. Both results are the same, so whether you do C equal to 60 because of a horizontal translation or A equal to negative because of a vertical reflection, either way you'll be correct. I'm going to do the reflection because that makes sense to me. So y equals negative 10 cos pi over 60t plus 11. And that's going to be my equation. All right, so that's the basic idea of taking the word problem, getting the picture, and then taking the picture and turning it into an equation. Let's go ahead and try another one. I'll go ahead and read the problem, and then we'll see if you can come up with the picture. An hour hand on a large clock on the wall of Union Station measures 24 inches, okay. At noon, the tip of the hour hand is 78 inches from the floor. At 3 p.m. it's 54, at 6 p.m. it's 30, 54, and then 78, okay? Find the equation that models the motion of the clock hand where x is measured in hours. So we've got ourselves some kind of clock here. And the clock is like above the ground. And we're looking at the little hour hand, which starts here, and then it kind of, it goes around the clock like this. It's kind of like moving around and around and around. Okay, so we could imagine something like this for our picture. Well, we're looking for, what are we measuring? We're measuring the clock hand. We're kind of looking at like the tip of that clock hand, like right here. So it starts there, goes down, and then comes back up. Okay, so go ahead and pause the video and see if you can come up with the numbers on this picture for what we have so far. All right, so based on the information we were given, we're told that at noon the tip is 78 inches, so this here is 78. And then we're told that it's 54, then we're told it's 30, then 54 again, and then back to 78. And this takes a total of 12 hours. So given those numbers, we should be able to find our values. A equals 78 minus 30 over 2. So that will be 48 over 2, 24. B is 2 pi over 12, so pi over 6. It looks like C is just 0 because this looks like a cos graph. And D will be top plus bottom over 2. And that should give us 54. Now, interestingly, when we look at these numbers, the length of the hour hand is 24 inches. And that corresponds to the amplitude of that graph. And if we notice, the midpoint is 54, and that corresponds to the D value. Sometimes people like to think of this right here, the middle of the graph is the midline, and the midline will be always the D value. So that 54 definitely makes sense. So we put it all together, and we would say y equals 24 cos pi over 6x plus 54. Okay, we'll do another one here, and I encourage you to pause the video and see if you can do the whole thing on your own. Read the question, draw the picture, and come up with the equation. All right, assuming you gave that a try, we have the daily temperature in March. It varies from a low of 24 Fahrenheit to a high of 40 at noon. Okay, so again, we're going to draw ourselves a graph. We have a low here of 24. We have a high of 40. And this is going to be something like that. This is midnight, which is kind of like 0 hours. This is noon. So I guess this will be after 24 hours, it'll come back down. Well, let's go ahead and crunch our values. A will be 40 minus 24 over 2. So 16 over 2. So for B, we have 2 pi over 24. So pi over 12. C, again, it's kind of debatable here. It looks to me like just a reflected cos, so I'm just going to set C to 0 for convenience. And D will be top plus bottom over 2. 64 over 2, so 32. And so we would get y equals, it doesn't say what letter to use. I'd probably use T because we're talking time here. -8 cos pi over 12 t plus 32. Okay, so again, see if you can give this question a try. Draw it out and come up with the equation. All right, assuming you gave it a try, the nice thing for this is we're not given as many words. There's no people involved, there's no clocks. We're just told that we have a trig function with a period of 7 and a maximum of 40 at 2 and a low point at -10. So to draw it is, I mean, well, kind of easy because we know there's a maximum right here. This is at 40 and 2. And then we know it's going to go down, so something like that. And we know the low point is down here at -10. So, I mean, there's so much information here. I guess maybe one other thing we could add is the period is 7. So I guess this point over here will be 9, right? 2 plus 7 will be 9. So that's how we know that x value. But I think we have everything we need. We do top minus bottom over 2. So 50 over 2, 25. B, I mean, they literally give us the period, so 2 pi over 7. C, we'll come back to C. And D will be 40 plus -10. So that should be 30 over 2, so 15. Now for C, because the graph doesn't start at the beginning, right? If the graph started here and went down, then we'd be good. But unfortunately, it starts a little bit offset. But that's okay, because this time we can actually use that C. This is the beginning of the graph. And so we can imagine the graph has been translated 2 units to the right. So C would just be 2. That gives us y equals 25 cos, big bracket, 2 pi over 7, little bracket, x minus 2, plus 15. All right, one last one to try. Again, please pause the video and give it an attempt. See what you come up with on your own. All right, so we have Caleb floating in a wave tank. At 1 second, Caleb reaches a maximum height. At 9 seconds, Caleb reaches a minimum height. We need the equation in terms of sine or cos. Oh, it says John's motion. Sorry, that's a typo. That should say Caleb's motion. Okay. So here we go. Let's give it a sketch. So we've got a wave tank. And there's water here. We've got Caleb sitting on the top of the water. And we know Caleb is going up and down in the wave tank. Well, maybe we could draw like this. So Caleb has a maximum of right here, 14 after 1 second. Then after 9 seconds, we've got a minimum down at 10. So we kind of have a Something like that. Not the best sketch. Let me give it another try. Something like that. All right, so we don't have the period, but I think we could figure it out. This right here from 0 to 9, this is a total of 8 seconds, and it's halfway because it goes from max to min. So this will be another 8 seconds, giving us a total here of 9 plus 8, or 17. And that means this whole time is 16 seconds. So that means the period is going to be 16. That'll help us finding our b-value. All right, so A, 14 minus 10 over 2, 4 over 2, or 2. B is 2 pi over 16, so pi over 8. C, well, again, it looks like the graph kind of starts here and then goes down, so we can just make C equal to 1. And D, 14 plus 10 over 2, 24 over 2, so 12. And so we would have y equals 2 cos pi over 8 t minus 1 plus 12. Now, if you were wanting, you're more than welcome to try to use a sine function on this for bonus, but I find that with most of the word problems, cos just tends to be a bit easier as a function. It just sometimes feels more natural, and so I generally use cos when I'm solving these. But if you solve it with sine and you think it's the same as a question on the worksheet, you're more than welcome to just type it in on Desmos. And as long as your equation gives you a picture that aligns with your picture, then you're definitely good to go. So just some quick notes here on what we've been doing. For this one, we are technically modeling word problems with trig functions. And the basic way to solve these is, obviously step 1 is you read the words. And sometimes you have to do this twice because, you know, reading is a little tough. English sometimes is a bit confusing. The second thing you want to do is you want to draw a picture. The picture helps us translate the words into some kind of graph. So by picture, I usually mean eventually. Even if you draw a nice little picture of Caleb floating on the wave pool, eventually you need to draw a graph. Then on that graph, you want to label your points. So in other words, you want to label the x and the y values. Because the picture might look nice as a rough sketch, but you need some points if you want to actually calculate stuff. And then you go ahead and you calculate your A, your B, your C, and your D. Generally using formulas. So A, B, and D are formulas. And C, well, that one's kind of tricky. But you look for a starting point. And then step 5 is you write the final equation. Again, usually it's going to be y equals A cos B x minus C plus D. Of course, maybe one thing to remember down here is that the letter x might be a different variable. It might be t, it might be maybe, what's another variable? It might be maybe s for seconds. It could be maybe z. Probably wouldn't be y, but it could be another variable, another letter. So you just got to watch out for that. Over here for your example, again, these are kind of long, so I don't want to write out a whole word problem for you. But just choose anything on Unit 6 worksheet 3. Go ahead and try one of those examples and you should be good to go. All right, hopefully you enjoyed this video, and as always, thanks for watching.